Hi, everybody. My name is Norm Johanson. I work for Amazon Web Services back in Seattle. And today we're going to talk about AWS Serverless with .NET Core. So this talk is not going to be too much about what is serverless. We're just going to focus mostly on the AWS implementation, because I know there's already a lot of sessions at this conference already on serverless. So what we're going to go over is what are the common AWS services that you will use when you're going to do a serverless application. Then show off what are the Visual Studio tooling to get started with .NET Core and Lambda. And then look at the command line tooling for users who are not doing Visual Studio or want to hook up this to their CI systems. And once we get an understanding of the tooling and how that works, we're going to take a look at what a real app scenario might look like. So AWS has like over 100 services right now, which is pretty remarkable because I've been at AWS for 7 years, and when I started there was 15, I believe there were. So we've had that much growth in that amount of time. And so we're not going to cover all those services. So I'm just going to focus right now on just what are the ones that you're going to most likely work with when you start working with serverless apps on AWS. So the first service, and if you've heard anything about serverless computing out there, you've probably heard of AWS Lambda. That is the compute part of the serverless architecture. This is the service that's actually going to run your code. It has a design of it's event-triggered and it's event-based scaling. This means unlike traditional applications where you have a collection of virtual machines that are running your application and you've got monitoring to see when you need to add and remove stuff, in this world, there is no compute power initially added to your serverless application. It's when those events come in, is when a Lambda is going to decide, hey, you need compute power, and go allocate that up. And this means your scaling is more of like, it's scaled by events. So if you suddenly get 1,000 events coming in all at once, then Lambda is going to go make sure you have that compute power available to you. And then when those functions are done, that compute power would go away. So you would only be paying for when your functions actually run and not that idle time. So Lambda supports Node.js, Python, Java, and last November we added .NET Core support. Amazon API Gateway, this is the front end of the AWS serverless architecture. So this is what's going to expose your Lambda functions out to the web. It has like web APIs. And it has other features as well, like managing authentication, versioning, monitoring, and more. Now, AWS Identity Access Management, this isn't strictly a serverless service, but it's one you're going to use regardless, because this is the service that manages your credentials and your permissions. So in Lambda's world, you're going to be using AWS Identity Access Management, or IAM, to basically give permissions to your code to access other AWS services. And you do that by defining a role, and you allow Lambda to assume that role, which will allow it to create credentials. And on that role, you can have a number of policies applied to it, which is what gives that Lambda permission to access S3 or whatever service you want to use. And so with AWS CloudFormation, you're going to be using this. You will most likely use this service as your serverless application gets more sophisticated, because you're going to find that you're going to have other AWS resources you're connecting to, and you got to keep track of all those events that you want to set up. So with CloudFormation, you can define your whole AWS architecture as a template file, which is usually a JSON file, that can be parameterized, and that allows you to just say, hey, CloudFormation, go create me this AWS stack. And it will go and create all those resources and set up all those events for you as a unit. And this could be like your test stack, your dev stack, or whatever. And then when you're done with it, you can just say, delete this stack, and it clears out all those resources. So it's a good way of keeping track of all those connection points for your serverless application. So those are the 4 main services we're going to talk about today. And so to recap, we have Lambda for compute, API Gateway is our front end, AWS Identity Access Management is going to be managing our permissions, and CloudFormation so we can automate our AWS architecture. Now, the easiest way to get started writing .NET Core Lambda functions is with Visual Studio and our AWS Toolkit for Visual Studio. We support 2017, which you can install from the Visual Studio Gallery, as well as Visual Studio 2015. For 15, you need to download that from our website. It comes down as an MSI. And 15 doesn't have .NET Core support in it by default, so you'll need to install the .NET Core tooling into that. Now I'm going to live dangerously and do some live demos, mostly to make up for my lack in PowerPoint skills. So we'll just go right into that. So if you've never used our AWS Local Visual Studio, the first thing you might notice is we have this window over here we call the AWS Explorer, which allows you to manage a lot of the common services developers use right inside Visual Studio, the ones that are managing data or messaging or in Lambda in this case. And you can also, up at the top, you can register profiles. This is basically, you can have a number of AWS accounts that you might want to have inside Visual Studio. You add new ones, pushing the new button, and you add in your AWS credentials. And AWS credentials are an access key ID and a secret access key. And what those are used for is underneath the toolkit, as well as in your own applications. When you're using the AWS SDK for .NET, it's going to use those credentials to sign the request to AWS, which is how we do authentication. If you ever can't find this view, you can just go under Views, and there's AWS Explorer right there. Now, to get started with Lambda, we need to create a project. So we go to File, New, Project. And under the Visual C# node, we have AWS Lambda. And we basically have two different project templates out there with the option of creating a test. The Lambda project is basically when you want to write a single function and you're going to work with the Lambda service directly. You're going to set up the connection endpoints, all that for you. And the serverless application is when you're going to work with CloudFormation to deploy maybe a number of Lambda functions together, as well as your other AWS resources. So we can get a better idea of how Lambda works, we're going to just do the Lambda project right now. We're going to call that image tagger, and we'll say OK. So once you do that, you're going to get a choice of blueprints, of basically things to help you get started. If you want to just go completely from scratch, you can choose the empty function, which has the minimal amount of boilerplate on there. These simple ones down here have the extra boilerplate on there for dealing with events coming from those services. And we have a couple that are more like tutorial ones. We're going to take a look at this detect image label, which is what it does is it's a blueprint that's going to be listening for pictures being uploaded to an S3 bucket. S3 is our object storage. And it's going to go use our image recognition service to find out what's in that picture, what labels are in there, and then tag our object with those labels. So we'll say finish. And here we can see it created our test project, and we've got our Lambda project here. Now, what a Lambda project is it is really just just a class library targeting NetCore App 1.0. We do only support NetCore 1.0. That is currently designated as the LTS version of .NET Core, and Lambda always has a policy with all of the runtimes to support the long-term supported version of that runtime. So if we look at our code here, regular C# code here, we got a couple constructors. Let's look at those. So the first one is just the empty constructor, which is creating a couple service clients from the AWS SDK for .NET. And you notice when we create these clients, we're not passing any credentials information or what region we want to connect to. And we can do that because when we deploy this Lambda function, we're going to assign an IAM role to that Lambda function. And the SDK, in its logic, when it's looking for credentials, we'll look to see, am I running in an environment that has an IAM role? And if so, grab the credentials for that role and make the request with that. Similar with the region, it will detect that I am running in EU West1, and we'll use that there. I could override all that by the constructor if I wanted, but it's generally best just to use the configuration coming from the environment. The rest of the stuff is the way this blueprint is set up is when we detect labels, we can say we only want to accept labels with a minimum confidence of that label. I think the default in here is 70%, but when you deploy a Lambda function, you can set environment variables. And so in the environment variable, we could override what that confidence level is. The other constructor here is passing in the clients, because this is what's used by the test project. Since the test project's not running in a Lambda environment, it's up to that test project to construct those clients. And so here is our actual function here. This is what Lambda's going to call. Takes in an S3 event. The Lambda context is going to give you information about the running environment. And this is an async method. And so just like all C# code, if you're doing an async method, you want to be sure to always return back a task. Don't do async void. Because what Lambda's doing is it's going to call this method and say, hey, you return back a task. I'll wait till that task's complete to know when you're done. So if you just did void, it would think that you were done right away. So we loop through our records. We're going to use, this is the image recognition service, where we're going to go detect some labels. Then we're going to go construct a collection of tags, S3 tags, and then use the S3 client to put those tags on there. So overall, it's a fairly simple code, but it's an easy way just to tie these two services together. Now, the other file we have in here is called the AWS Lambda tools defaults file. So this is the file the blueprint or the blueprints put in there to help set up a lot of those initial values when you deploy the function. We're going to take a look at a couple of them. Function handler is probably the most important one, because this string is what identifies to Lambda what is that C# function I want to call in my class library. So it's identifying the assembly, the type name, and the actual function in that class to call. The other thing that I think is worth pointing out is memory size. I wanted to call that out because it's more than just memory size. The way I always look at this property is more of it's a slider on the amount of compute power you want to give to your Lambda function. Because what Lambda does is, as you increase the memory, that also scales how much CPU and network power is added to your Lambda function. So with those all set, let's take a look at how we deploy it. And to do that, we right-click on our project and we say publish to AWS. It's going to bring up our wizard, and you can see there's those values already set because they came from that file. So we just need to put in a function name. We'll call it image tagger. And on the second screen, the most important thing we got to do is this is where we're going to set the IAM role. This is what's going to give permissions for our function, because our function has to access our S3 bucket, and it's got to be able to access the image recognition service. So we could define a role with those policies. Now, for me right now, I've already set up an existing role that we're going to use. I could create one with some of the pre-canned policies that we have out there, or if you have some policies that you've already set up on your account, I would be able to create those. But we're just going to select that one. And here's where I could set an environment variable. So if I wanted to override that minimum confidence level, I could pass in a value there. But we're not, so we're just going to say upload. And so this is basically doing a .NET publish with the CLI, zipping that up and telling Lambda, go create a Lambda function. And so we bring up this view of the Lambda function, which is coming from the AWS Explorer. You can see image tagger there. And we can do a few things in here. We can modify the configuration of it. We can also just do a test invoke right from here. There's some sample requests of what you might send to S3. For example, here's the request. Here's an example of what a request would look like coming from S3, where it identifies the bucket that you want to say there was a new object created and the object. Those don't exist. I'm going to go ahead and push that anyways. This is not going to work, though, because those objects don't exist. But you can see how, right from here, you could modify that file to something that really does exist to test how things work on production. And you can see here's the error of not being able to access that object. What that also allows me to do is, in the logs view, we can get a list of the logs. So we can see what really happened in here. So here's some of those print statements. I don't know if I showed that, but all of the console writes in here will be forwarded to the CloudWatch logs that are associated with that. So that's how you get your log messages there, and you can see there's the stack trace. So now we have our Lambda function deployed. It's got permissions to access the service. But now what we need to do is we need to actually hook this up to our S3 bucket. So we can do that in the Event Sources tab. This has some of the services that you can connect with with Lambda. A lot of the other services, you need to go to their web console or use their SDKs to do that connection up. So here we'll say add. S3 is already picked. You do need to pick a bucket that's in the same region as you. So I happen to have one called EUS1. Prefix and suffix you can use to sort of filter which objects you want to get events for. We'll say OK. And so now they are connected. So when we add objects to that S3 bucket, this will cause our Lambda function to be invoked. We can test that by, if we go over to S3 in the toolkit, here's that bucket here. I'll open up its view. I don't have any objects in there currently. So let's copy some images of my family in there. We'll upload those. So now as these are being uploaded, this is going to then trigger those events to, from S3 to Lambda to go do that logic we had. So they're connected without actually running any service to do that. So that's uploaded. We should see by now, and if we refresh the logs, I'm betting, there was it doing some of its work of getting those tags. We can get a better view of that if we go back over here, and let's see how well this service did. So here is my daughter playing on the beach. See what did they think of that? So on that, we can do properties, we can go to tag, and we can see that she is a human. There's water, she's on the beach, she's having a good time there. Let's try this one. Anybody want to take a guess where this is a picture of? Anyone? Yes, I did convince the family to go to New Zealand this year, and I don't think my wife appreciated doing all the Lord of the Rings things, but it was fun. So what did we do on the Shire there? I said there was a chair, we got a pumpkin out there in the garden, there's furniture, squash and vegetables. It didn't pick the hobbit holes, but that is kind of a custom case. So there you go. This is how you can easily write these Lambda functions and hook up these services to do more interesting things without even having to run servers with that. So to recap, get the toolkit to try things out. 2017, get it from the gallery. 15, get it from our website. You can use the toolkit to manage your AWS credentials. You can also use the toolkit to get blueprints to get started. You do need to have, it's a class library targeting Netcore App 1.0. And in the toolkit, we can deploy functions, and we have that defaults file to help us with a lot of the initial values for deployment. So now let's take a look at the command line, because we know with .NET Core, we can do things more than just inside of Visual Studio. So let's bring up a console here. And so the first thing we want to be able to do is we want to create a project. And in Visual Studio, right, we had all those blueprints to get started. Well, it turns out when they GA'd the .NET Core tooling this winter, they added support in that .NET new command to add new templates to that. And we've added things to that. So if we say .NET new -i for install, we can say Amazon Lambda templates, : star. : star means use the latest version. That's going to install that NuGet package that we have and put all those blueprints that we had in Visual Studio right there on the .NET new command, which I already have done, so I'm not going to run it again. So if we say .NET new, you can see there's all those Lambda functions right here. So we can do these anywhere we are. I'm going to keep this demo simple, so I'm just going to use that empty function blueprint. We can get help on that if we say .NET new Lambda empty function help. And this is telling you that you can pass optionally in the profile, if you use on Visual Studio, or the region, or both. And what that's going to do is it's going to inject in that default file it's going to create. It's going to set those up for you. So when you do the later deployment from the command line, you don't have to keep entering those in over and over again. So let's create this. .NET new Lambda empty function. I have to spell it correctly. Profile, we'll use my normj profile. Region is EU West 1. And I'll name this demo func. That looks right, yeah. Project is created. So let's go into that directory. We can go use Visual Studio Code and see what we got here. So here again, we got our test project, so we can see how we can write some integration or unit tests, and we have our code. The empty function is very basic. All it is it's just trying to give you some code to get started with. It's just doing a 2-upper on the string passed in. So you can take that and go do whatever you want with it. So what we need to do now is, well, how do we deploy this function? And what we did is, if you look in the CS proj file, we installed a .NET CLI tool reference to the Amazon Lambda tools. So this is going to add commands into the .NET CLI so we can manage the deployment right from there. In fact, it's the same code that we do in there that we do in Visual Studio. And so that menu item in Visual Studio to say whether to publish or not, how we choose to show that is that we look to see, is this a .NET Core project, and does it have this dependency? If it has this dependency up, then we assume this must be something you want to deploy at Lambda, and so we'll add that menu item there. Okay, so let's deploy it. So let's go to our function, and we need to restore references. So it's going to pull in our tooling in there. And now if we say .NET Lambda help, you can see these are the commands that have now been added to the CLI. This first section here is dealing with just the Lambda projects like we just did in Visual Studio. The second set is for the serverless lab when you're doing deployment with CloudFormation. And the bottom two are sort of utility ones for when you want to maybe hook this up to your CI system and you want to just use this to get everything packaged up right for Lambda. All right, so then to deploy that, we would do .NET Lambda deploy function. All right, well, let's look to see what that takes. If we say help, you can see that takes a fair amount of parameters, and that's where that default file comes in really handy because most of this is already set for us. The only thing we really have to set at this point is what is the function name and what is the IAM role that we want to use. So we'll say .NET Lambda deploy function, and I'll call it demo func. And I don't remember my role, so if you don't enter the role on the command line, it's going to prompt you for that as you're doing the deployment. So you can see here, what role do I want to use? And I'm going to say, I'm going to use that same role I did in the previous demo. And there it is. It's created. So we could now see if we did .NET Lambda list functions. We can see there's our two functions, the one we did in the previous demo and the one we just did. We can also do some testing of the function right here. So we know this function just does a 2-upper is all it does. So if we say .NET Lambda invoke function demo func, and we pass in a payload, we'll say hello NDC. We say return. So this will run that function just like that sort of test view in the toolkit. We can run it here on the command line. You can see we've got a cloud 2-upper function now. Now you might be wondering, why did it take 800 milliseconds just to do a 2-upper on that? The reason was this was the first time this function was invoked. So that's when Lambda had to then go and allocate the compute power needed for this function, download the function from S3, and start up the .NET runtime. If I have to run it again, with all that stuff already warmed up, you can see from Lambda's point of view, it was much faster there. Okay, so that is the CLI. So again, to use the CLI, you want to do a .NET new to install the templates right there. That gives you all the blueprints we have in Visual Studio. Then you can just do .NET new to create your projects. And then you do .NET Lambda deploy function to start deploying it right from the command line. Okay, so my real app scenario, which admittedly the demo didn't get as fully completed as I had my ambitions for, was an app called Pollster. And what this app is it's a website for customers to put up polls and everyone can vote on those polls. So my requirements is I need a website that everyone can access, vote on those polls. Every poll has a start and end time, so I'm going to need sort of a state machine for these polls. And again, I'm being serverless. I want to do no servers with this application. So to do this, we're going to introduce a couple more services. Some of these you might have heard. Amazon DynamoDB. This is our managed NoSQL database service. And for us, what we need to do is we need to create 2 tables out of that. One is a table to store our definitions for the polls, and the other one is to storing the list of the current active polls. And a nice feature DynamoDB has is you can enable streams on that, which sends out events of your items being changed in your tables or new items being added. And as you can guess, with those events, you can hook up Lambda to then process those events. And so we can use those to start our workflow on that. So the other new service we're going to talk is AWS Step Functions. And this allows us to define a state machine. That basically, in our case, the state machine is fairly simplistic. It's just a scheduling of, I want to state when I want to schedule it, how long do I wait till I activate it, and then I got to deactivate it after a certain amount of time. And each one of those states where there's work to do, those are called tasks, we can say, when you hit the state in the state machine, go call a Lambda function to do that work. So again, we can keep with being serverless for doing all that work. Now, one of the interesting things that we've been doing lately with our .NET Core tooling is we've been doing work to be able to run ASP.NET Core apps right on top of Lambda. Now, I'm not saying this is the right solution for every .NET Core Lambda project, but if you happen to really like writing your web apps using ASP.NET Core, or you're not ready to learn a new programming model, you can do this way. Because it allows you to use the same programming model we already know. We can just run it locally in IIS and test it all there, and then when we're happy, we can just go deploy that to Lambda. The cons are, because we are bringing a larger framework, there's a little bit more to be initialized during the startup. So you want to be very careful about what it is in that startup CS that you're really doing, because that's going to be invoked during the initial code start of the app of this function. Now, it's not done for every single one of the executions. Basically, what happens is when Lambda starts up that first code, the first time it's executing that function in that compute environment, is we initialize the whole ASP.NET Core framework so that the next request will be fast. Also, Razor views are not supported doing this, so we need an alternative framework for our client code. So what I'm doing is I'm doing everything in Angular for that. With that, let's go into another demo here. So here is Polster. Again, this looks like a regular ASP.NET Core application. We have controllers here like we've seen many other places. There's controllers for getting polls and the feeds and voting on those. We have our program CS down here, which is starting up Kestrel, like with that. So that way we can easily just do F5, and we can run this application locally. We can do our local development, test it there, and see what it looks like. Let's see how we're doing. So here it is. Where should I take the kids for vacation? So far I've liked Norway. I think I might make them go to Norway. I think the kids want to go to Disneyland. We'll see how that works out for them. Okay. But now to get this to work in Lambda, what I've done is I added that NuGet package I talked about earlier, and I have a new class in here called Lambda entry. The name's arbitrary. You can call it whatever you want, but it extends from this class API Gateway proxy function, which this has one method you need to override, which is the init method, which looks a lot what we saw in the program CS, where you need to set up the content routes, say what is the startup class. But instead of saying use Kestrel in IIS, we have to say use API Gateway, because that's going to be our web server in this case. Now, the actual Lambda function comes from the base class. It is this function handler async that's actually going to be called. That's the only code changes we actually did to this application to make it run on Lambda. Everything else is the same as you do on ASP.NET Core. Now, the other things we have in here is under workflow, this is my state machine test. So these are my series of Lambda functions that I'm going to use for the states in my state machine. And these are all fairly simple ones. They're going to take in a poll state object, and it's going to grab that poll ID, find out how long till we should schedule it, and set that seconds till active on that. And we're going to turn that back, and that's what the state machine is going to use to figure out how long to wait. And that logic's sort of similar for the activate and the deactivate. So we have these other Lambda functions in there. And we also, this is going to use more parts. So this is why we're not just deploying straight to Lambda. We're going to use this as a serverless app deploying with a CloudFormation template, which is what this serverless template is here. And if you look in that defaults file, we specified template is serverless template. So now when we deploy it, the wizard's going to be a little different. In fact, let's deploy it first, because it takes a couple minutes for it to come online, and then we'll talk about what's in that template. So you can see the wizard is simpler. All we really have to do now in the wizard is specify what is the name of the CloudFormation stack, and what is the S3 bucket that we want to use to store our compiled application bits when we do this deployment. If I had parameterized the template, there would be a next button in there for me to enter those parameters, but for this example, I didn't parameterize that. So we'll just go ahead and publish that. It's going to do the similar thing. It's going to compile the app, zip it all up, send it up to S3, and then we're going to basically tell CloudFormation, go and create this CloudFormation stack with these resources. So that, in a second, is going to bring up a view. While I drink some water. And here is the CloudFormation stack view coming from the Explorer. You can see it here. And this is going to start streaming in the events of these AWS resources coming online for us. So while that's going, let's take a look at the serverless template. So a template has, you can define parameters, which I didn't in this case, and then you have your collection of resources. So let's look at that. So I mentioned I needed 2 tables. So here is my definitions table that's being created and my active polls collection. And down in the DynamoDB table, since it's a NoSQL, there's no schema. All we need to do is define what is the key. And I mentioned that we can enable streams on this. So that's where this is at. So this is going to enable streams that we can hook up a Lambda function to capture when new polls are created and start that workflow execution. And there's my active poll. And then we have the ASP.NET Core function. So this is really the Lambda function that represents the whole ASP.NET Core app part of this. Its type is of serverless function. That's sort of a meta resource, because what it's going to do is it's going to create more than just a Lambda function. It's going to also set up our API gateway as well. That's this event section here. So the events is going to say, hook this up to type API, which means API gateway. And normally, or a lot of times what you'll see is that when people create a serverless application, they'll use API gateway and define all of their endpoints in their REST application. But in this case, what we've done is we're just saying send all requests to our Lambda function. Because since this is an ASP.NET Core application, we're going to rely on ASP.NET Core to route to the right controllers for us, and for any HTTP method. The other things going on here is we can pass environment variables in, so we're going to pass in the names of those DynamoDB tables that just got created as part of this template. So, because initially, I just had my 2 tables that I was using locally, but now I suspect I probably have a couple more that just got created based off my CloudFormation template. Here's my state machine. So this is saying use this role to run the state machine. I should have mentioned also, in that Lambda function is when we specified the role it used. So we have 2 roles we're using. Here's the role the state machine has. So that's giving our state machine access to invoke our Lambda function. Because by default, you never have access to things in AWS. In AWS, you always have to tell it what you're allowing things to do. Nothing's going to act on your behalf unless you say it's OK. And then there's the definition string, which you might be wondering, why is that blank? The reason that is blank is we added a little extra tooling in our .NET tooling so that in our defaults file, we can say with this substitution, replace the content of that by this JSON path with this contents of this file. The reason we did this is now I could define that state machine in its own separate file and not have to try to define it in an escaped JSON document inside of a string. So if we look at that state machine, you can see here's all those states, right? We've got our scheduled state, which is going to call that Lambda, and that return back that property set of seconds till active. So that's going to wait that long. Then we go to activate, wait again, and so on. So again, this is a fairly simple one. We could do more complicated things, but we didn't need to in this example. So then here's our collection of defining those Lambda functions for each of one of those we're going to use inside our state machine. So there's that schedule task Lambda function, active tasks, activate task, and deactivate. You might be wondering, why are all these code blocks empty? And it was empty as well for the ASP.NET Core function. The reason is when I write this file, I don't know where the code's going to be, because the code was uploaded as part of our deployment. You saw that was that first step in that deployment wizard. What the wizard is doing is it first uploads everything to S3, then reads this template file and goes and autofills in all those properties to where I just put the bits at. So you're not having to manage that. And then the last real resource we have here is, this is that DynamoDB processor. This is the function that is going to go listen for events coming off of my DynamoDB table. And so I can start those workflow executions. So here I'm passing in those environment variables of, again, those tables that I'm using, and also now the state machine that just got created. And then in the event section, I'm saying this is hooked up to DynamoDB to this stream. This is the stream coming from that poll definitions table. So here I've defined now all of my AWS resources in this file that I can just deploy as one unit. The last thing that we need to talk about is permissions, right? Because we have to give access to these AWS services. They don't have that by default. So here's that role I defined for state machine, which basically says here that AWS step functions is allowed to assume this role when it's working with our state machine, and it has access to call the operation invoke function. So that's the only thing state machine can do, or step functions can do on our behalf. And the other role here is the one we're going to use for all of our Lambda functions. So that's why we're saying that this can be assumed by Lambda. So these are all the permissions our Lambda function can do. And there are a couple ways you can set up policies. You can use managed policies, which are, there's either you can create your own policies that you can share in your account, or there's policies that the AWS services provide. So here is a managed policy that the Lambda team provides, which basically is going to be giving me access to write to CloudWatch logs. But now I also want access to DynamoDB as well. So this first, let me open this a little wider here. First rule here is saying I basically want all the CRUD operations for DynamoDB for only those two tables. So there's no way that my Lambda function can affect anything going in any other tables. And I need to give access to the stream, be able to access the stream so we can get those events. And the last thing we need to do is we have to give permissions to start the execution of our workflow. And that's it. Now I'm betting our stack is complete. It really took about, I think it takes about a little less than 2 minutes. Let's see. My computer's on Seattle time here, but so it started at 9:11 a.m. in Seattle and finished at 9:13. So to create all that stack and all those resources took about 2 minutes to do. Now I created brand new tables for this application, so I don't currently have any polls in my application. So to help this out, I did create one of my web controllers is one just for adding sample data, which is going to go read in this JSON file sample polls. So let's just go ahead and run that. I'll use Postman for that. I am not going to do an update in the middle of a demo. And so we'll say API sample data as a post. Send that. So this is going to go and add those tables to my definitions table, which is then going to trigger off events coming off the stream, which that DynamoDB stream processor is going to find and kick off the executions of those, the workflow executions, which then step functions is then going to say, well, let's start the flow of that and start scheduling those tasks or polls. So if I go into the web console, there's step functions. The first one was from a different practice I did earlier today, but so this is the one I just created. You can see here's the executions for the 3 polls I just created, and they're all currently in that sort of wait to deactivate, because the way I set up the sample data is I wanted them scheduled for now. If you see it, what it took in is it's got that poll ID, which it was 0 seconds to wait to activate, and now it's going to stay there for that many seconds, 12,000 seconds or so. So there's all that hooked up. So now if we go to the website, you can see we have now deployed our serverless application using all those moving pieces together as one CloudFormations template, and we can start using it. So I can say I am currently using Windows. Chewbacca is the unsung hero of the Star Wars movie. Where should I go in Norway? I am not going to try to pronounce any of these names, but I thought I would go to this valley to do some hiking. I don't know how to say that name, though. There we go. So there is our serverless application, all deployed together as CloudFormation template without using any servers for this. Okay, how am I doing on time? I have a little extra time here. So the one thing that I was thinking about this last night while going through this again that's bothering me about this is we are using Lambda functions to deliver the static content, right? Because this site has CSS, it has JavaScript, it's bringing those Angulars, and using Lambda functions to bring down static content is probably not the best use of Lambda functions. That's what we have S3 for using bringing down static content. So, like I said, this guy's API gateway definition is fairly simplistic, right? It is, if we look at API gateway, this is that service. It's just a proxy to send everything in there. So alternative I was playing with last night, which is something I've been wanting to add more tooling with and say how we make this easier to set up, is what if we use S3 to handle all of the JavaScript and CSS? So when this is from my other account here, this guy's implementation. You can see what I did here is I still have that proxy to send everything to my ASIC core, but I have for the CSS and the dist folder, I have a proxy that says, send everything to my S3 bucket. Same with this one. And so I've copied all those static content to that one. So in this case, to show what I'm talking about, if we look at, this is poster, here is the ASP.NET Core application, the Lambda function ASP.NET Core, and the demo that we've already been doing today. If we look at, let's just clear these logs. Start it from scratch here. And if I refresh this, now we refresh this to get the latest logs. You can see we got quite a few of these logs coming in through. The reason why I got multiple is because there's multiple compute environments currently going on, so we got parallel requests. And so if we look at this side, we can see this Lambda function is being spun up just to return back this site CSS file. And those other ones are there. Right? So in this other, let's take a look at my other implementation here. Again, it's the same code in the other one. I just re-engineered the API gateway layout. So let's go there. And so here is this guy's Lambda function. I'll delete its log so we can see what just happens for that. Get the URL from the stack. Hopefully I left the polls in here. So this guy now, if we looked at its Lambda function, at its logs, you see in this case, we just had two requests. We had one for the main page that's basically controlling the base path for Angular, and then just the web API to get the poll feeds. So there's a way you can use API Gateway to basically reduce some of it for the asynchronous core to take static content and push that back into S3. Okay. So with that, we can see how we can run ASP.NET Core apps on Lambda. You do that with the Amazon Lambda ASP.NET Core server NuGet package. Obviously, Poster, you might not be the easiest way to just get started, but you can actually just get started in the blueprints. There is a blueprint under Project, Serverless. There's an ASP.NET Core blueprint that has that already set up for you. And I did have a blog post I put out there that walks through how you could take an existing ASP.NET Core application and deploy it this way if you want to try that out. We also learned how we can use CloudFormation to manage our whole architecture out there for us. And we used AWS step functions to define our state machines so we could control when our polls became active and deactivated. With that, some final links for everybody. The toolkit out there, again, 2017, you can get it from the gallery, 15 from our website. All of the .NET Core Lambda tooling, the CLI stuff, the libraries, I do all that work out in GitHub on AWSLambda.net. So if you ever have any questions or issues on how to deal with .NET Core and Lambda, feel free to open up an issue or question there, and I'm happy to help people out. I took a snapshot of my poster code last night, and I stuck it up on this repository. If you go to that repository, there is a talks folder that has it in there. And I put the slides in there as well. So if anyone is trying to take pictures, you can just get it from there. And I contribute a lot to the AWS.NET blog. So I write a lot about .NET and AWS. Lately, I've been writing about a lot of Lambda and .NET together. And with that, thank you so much for coming. I don't know if anyone has any questions, feel free to ask, but otherwise we can go. Yeah.
You mentioned regional constraints on the S3 bucket. Does that go for all of the resources in AWS that you want to use?
No, usually, sorry, the question was is there region constraints when working with AWS? Usually with services that have events connecting up to each other, so if it's like a Lambda connecting up to another event, those need to be in the same region. But I can definitely have my Lambda function that's then going to go access buckets in other region. But you're not going to be able to, I don't think there's any service that has events that you can send cross-region. So, yeah.
I know you get quite a lot of Lambda functions for free. But is there any cost implication of moving your CSS into S3 buckets?
There is, I mean, S3 you do have to pay for the getting objects out, especially for small little files, though. It takes a lot for that to be significant. You'd have to, the question is, sorry, of what is the cost for going to putting the static content in S3? It would be the cheaper option than having it being delivered by Lambda. So, you,
How would you recommend us to test lambdas or step functions, maybe locally, if it's possible?
Step functions, the way I've always done it, admittedly, I've just really been starting to look at step functions lately myself, mostly for this demo, is you're really just going to be writing XUnit integration tests like that. There's not a way to really just run step functions like in a local environment. Yeah. Yeah.
Are metrics around the lambdas also pushed to CloudTrail?
So the question is about metrics, and so there are metrics. The metrics are shipped off to CloudWatch. I know we have lots of names to figure things out. Well, actually, so CloudWatch is the main place to get logs. If you looked at the Lambda console, that has more detailed information than we have in the toolkit right now. So like here is the function that we just did. It has monitoring tabs. You can see some of the metrics there. And then you can go to the CloudWatch console to drive deeper into that. Any other questions? All right, let's call it a day. All right, thanks everybody.